Hello class, today we're going to talk about horizontal and vertical asymptotes, specifically of rational functions. So we're sticking with rational functions for a bit, and let's just review. An asymptote is a line that a curve approaches as we approach infinity. So here, in the green, I have graphed a function, and in orange, it's asymptotes. Notice that it has one horizontal asymptotes and two vertical asymptotes. And these functions won't touch them as we go towards different infinities. They'll get closer and closer, but they'll never touch them. So there are three types of asymptotes, as you may know. One is vertical, it's straight up and down. The other is horizontal, straight left and right. And then oblique, which is at an angle, but it's still straight. Not horizontal, it's, what do you call it? Diagonal, there we go. So, but today we're only going to talk about how to find vertical and horizontal. Oblique requires division of polynomials, which we'll get into later. But let's just talk about vertical and horizontal for now. So, to find the vertical asymptote, or the VA, we set the denominator equal to 0 and solve for x. So remember, the asymptotes, it doesn't touch it, and that kind of makes sense because we can't divide by 0. So when we want to know when it equals 0, that's where our asymptotes lie. To find the horizontal asymptote, it's very similar to what we were doing last lesson. Think we have a numerator and denominator, and we have three different outcomes. One is that the degree of the numerator is larger than the degree of the denominator. So if the degree on top is larger than the degree on bottom, there's no horizontal asymptote. Instead, it will be an oblique asymptote. But for our purposes, when I ask for horizontal, just say none, because horizontal is different than an oblique asymptote. And then we have the case where the degree of the numerator is equal to the degree of the denominator. And that is just the ratio of both leading coefficients. Very similar to when we were finding the limits, right? In fact, they're very much so related. And then finally, we have the degree of the numerator is less than the degree of the denominator, and that means the horizontal asymptote will be 0. Again, very similar, right? So here I have three examples, and it's an example of each kind of thing you'll run into when solving for these. So let's go through these one by one and figure these out. So the first one, well, let's just remember we want to find the vertical asymptote and the horizontal asymptote. I'm just abbreviating them, right? So let's start off with the vertical one. Let's start with the horizontal one, because that's just kind of a test of the eye, right? Well, we see that the degrees of both are the same, so that means it'll be the ratio of both leading coefficients. And remember, there's no number here, just 1, so 3 over 1 is just 3. So our horizontal asymptote is when y equals 3. Okay? I guess I should not put equals here, I should put the colons there. Okay. Okay, so we found the horizontal one, easy, right? Let's find the vertical one. And that one we set the denominator equal to 0 and solve for x. So we have x squared minus 25 equals 0. Now notice what we have here. We have an x squared term, and then we just have a constant. In that case, we can just solve for x by getting x squared by itself. So add 25 to both sides. We have x squared is equal to 25, and then take the square root of x squared, which will give us x equals positive or negative 5. Now, we're going to get two answers, remember, because it's squared. A positive 5 times positive 5 equals 25, and a negative 5 times a negative 5 equals 25. So our answer here, now the vertical asymptote is an x value, so x equals plus or minus 5. So we just determined the two, or in this case, this one is 3, asymptotes, right? One horizontal and two vertical. So let's take a look at one over here, and again we're going to have to find the vertical asymptote and the horizontal asymptote. And again, let's find the horizontal one first. That's generally the easier one. Here, well, the bottom degree is larger than the top degree, so it's just going to be y equals 0. That's always the case when the degree of the bottom is larger than the degree on top. And then here, well, we're going to set it equal to 0 and solve for x. X squared plus 6x plus 9 equals 0. But notice we have an x squared term and an x term. We can't solve like what we did last time, but you can either use the quadratic formula or easily you can factor it. So when we have factors set equal to 0, you can set each factor equal to 0 and solve for each x. So remember, we need to find two numbers that add to the middle number and multiply to the last number. Where's my So the two numbers we're thinking of are 3 and 3. 3 plus 3 is 6. 3 times 3 is 9. So x plus 3, x plus 3, and set each one equal to 0 and solve for each x. But in this case, you see they're the exact same, so that's okay, that you get the exact same. X equals -3 over here. So that just means we have one asymptote right there at -3. So the vertical asymptote here is x equals -3. Okay. Let's take a look at the final example. So we have a vertical asymptote again and a horizontal asymptote. And let's find the horizontal one again. In this case, the degree of the top is larger than the degree of the bottom, which means there is no horizontal asymptote. Remember, it means that there's an oblique somewhere. And we get that by actually doing division of these two polynomials, which I'm sure you all remember from pre-calc. Very fun. But let's find the vertical asymptote. So here we're going to set it equal to 0. 4x squared minus 8x equals 0. In this case, you can factor, but it's much easier just to pull out a greatest common factor in this case. Notice what I'm going to do here. I have an x squared term and an x term, and it's a binomial. I'm just going to pull out an x out of both. And 4x squared divided by x is 4x. Negative 8x divided by x is just -8. And then let's just set each factor equal to 0. So we have x equals 0 and 4x minus 8 equals 0. And solve for x. Well, this one's already solved for. And this one, let's see, plus 8. I'm going to go up here for more room. So we're going to have 4x equals 8. And then divide both sides by 4. X is equal to 2. So our vertical asymptote is x equals 0 and x equals 2, just like that. So that's all I have for you today. Let me know if y'all have any questions, and have a good day.